All right, holding a slope. So we have a book that's resting on a table and it's inclined at an angle to the horizontal. When the angle reaches 20 degrees, the book begins to slide. So we've got a table and the angle is increasing, 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 gets to 20 and the book begins to slide. So we want to use this information to find the coefficient of static friction between the book and the table. So let's set up our free body diagram. So let's say this is the table and it's inclined to the dotted line is the horizontal 20-degree angle. So let's set the x-axis along the table and the y-axis perpendicular to that. Make things easy. So this dot will represent the book. And we know we're going to have a weight force. It's going to be acting straight down towards the center of the earth. And we're going to have a normal force, which is going to be perpendicular to the table. And we are going to have a static friction force, which is going to be acting this way. And so we know our big idea here is that F net is going to equal 0. This object is at rest, this instant before it starts to slide. And so we have some x component of the weight, so we've got to have this static friction counteracting that, so we get a net in the x direction of 0. So if F net equals 0, then F net in the x direction must equal 0, and F net in the y direction must also equal 0. So we've started to talk about the x and y components of the weight force. So let's find those and we can proceed with that knowledge. So this is going to be the x component of the weight force, and the y component is going to be this. So it's going to be Wx and Wy. So we can use trig to figure out what Wx and Wy are equal to. So we know this angle is going to be 20. And this we can prove because we see, there's a right angle. So 20 and this is 90. We know it's going to add up to 180. So if this is 20, then this must be 70. And we see that this right here is a right angle. So 70 and 20. So that's 90. And so, of course, this is 20 as well. So sine of 20 is going to be equal to opposite over hypotenuse. So we see the opposite of W is Wx, and we see that the hypotenuse is W. So we can say that Wx equals W sine 20. And now that is going to be negative because it's in the negative x direction here. So we can see Wy, we can use the same kind of thinking here, and we'll see it's going to be negative W cosine 20. And again, it's negative because it's in the negative y direction here. So keep in mind everything we know about vectors. So now we can think about the expression for the maximum force of static friction. And this is the maximum force of static friction because this is the instant before the book starts to slide. So if this were to be any more angled, the book would start to slide. So that's going to be equal to mu s times the normal force. So, okay, let's figure out what the normal force is. So, like we talked about, F net y right here, it's got to be 0. So the normal force has got to be equal to the y component of the weight force, which is negative cosine 20. So we can go ahead and plug that into our negative, I'm sorry, negative w cosine 20. So we can go ahead and plug that into our expression. And that equals force of static friction. And since we know that F net x must be 0, the force of static friction is going to be equal to the x component of the weight force. So force of static friction equals Wx. So we can go ahead and plug in Wx for the force of static friction. Right up here we see that's negative W sine 20. And now we get this. Negative W cosine 20 here. So we can go ahead and divide both sides by negative W cosine 20. And we wind up with mu s equals sine 20 over cosine 20. So these negative W cancel out. So we can see that mu s equals tan 20. Sine over cosine is tangent. So we can plug that into our calculator and get our answer for the coefficient of static friction.